RPC Falsification Whitepaper. For peer review, June 2026. Chris D. Seeley, Independent Researcher, Canada. Abstract. 3 leading frameworks in contemporary theoretical cosmology share a critical property: they are not falsifiable by design. Consciousness priorholographic models like Hoffman and Kastrup, many worlds quantum mechanics from Carroll, and infinite-multiverse fine-tuning solutions from Krauss and Susskind all invoke unobservable mechanisms that cannot be tested. Recursive Partition Cosmology, or RPC, and its near-extremal Kerr formulation offer a framework that is falsifiable at every stage. More importantly, RPC's core axioms place explicit logical constraints that are incompatible with infinite branching, consciousness-dependent collapse, and multiverse ensemble statistics. This whitepaper presents 3 mathematical incompatibilities between RPC axioms and competing frameworks. It also presents 5 empirical tests that distinguish RPC from alternatives. Finally, it documents 1 confirmed zero-free parameter prediction, the SPARC rotation curve ceiling showing 174 of 175 galaxies at or below 298 kilometers per second. The framework is falsifiable. 2 predictions are already constrained. 3 others are testable within 12 to 24 months. Section 1 Incompatibility Proofs. 1.1 Global conservation versus many worlds branching. Axiom A1 from RPC states exact global conservation. All partition states must satisfy the sum of all U subscript I equals 1 at all times. Claim from Carroll: quantum branching creates n-disjoint universes at each measurement. Incompatibility proof: if branching occurs n times per second across the observable universe volume of 10 to the 27th cubic meters, and branching has occurred for approximately 13.8 billion years, then the total information content across all branches is 2 raised to the power of 10 to the 120th bits. By the Bekenstein bound, the total information must be less than or equal to the horizon entropy S subscript h, which equals the ratio of R subscript h to L subscript p squared, approximately 10 to the 123rd bits. Since 2 raised to the power of 10 to the 120th is much greater than 10 to the 123rd, global conservation is violated. Status: incompatible. No test required. This is a logical contradiction. 1.2 No zero axiom versus consciousness-dependent collapse. Axiom A4 from RPC states that 0 is not admitted as a number, operator, or limit. Claim from Hoffman: consciousness collapses the wave function. Unmeasured reality is indefinite, potentially having 0 amplitude. Incompatibility proof: in quantum mechanics, the collapse postulate states that if psi equals c subscript 1 times state 1 plus c subscript 2 times state 2, then measurement by observer O produces eigenstate I with amplitude c subscript I going to 1, and all others going to 0. The unobserved state J has amplitude approaching 0 until the next measurement. In Hoffman's model, unmeasured reality is ontologically indefinite because consciousness has not yet defined it. This indefiniteness is modeled as amplitude 0 for unobserved states. RPC forbids this. Axiom A4 states that 0 cannot appear as a limit or operator. Therefore, unmeasured reality cannot have amplitude 0. All partition states must have non-zero amplitudes at all times, regardless of observation. Empirical consequence: the early universe, at redshift greater than 10 with no conscious observers, must obey identical physics to the present-day universe. Spacetime geometry, particle masses, and coupling constants must be observer-independent. Test: do galaxies at redshift greater than 10 observed by JWST have identical stellar mass function, rotation curve scaling, and element abundances as galaxies at redshift 0? Or do they show signatures of observer-dependent physics? Status: observationally falsified. JWST observations by Labby and colleagues in 2023 confirm identical physics at redshift 13.5 compared to redshift 0. 1.3 Finiteness versus infinite multiverse ensemble. Axiom A5 from RPC states that infinity is not admitted. All partition states are finite. Claim from Krauss and Susskind, fine-tuning is solved by an infinite multiverse ensemble with statistical variation in physical constants. Incompatibility proof. If the multiverse is truly infinite, then all possible values of physical constants occur with equal prior probability. Fine-tuning becomes statistically expected in the limit of infinite universes. No specific constant value requires explanation. RPC forbids infinity by axiom A5. Therefore, no infinite multiverse exists. There is exactly one universe with exactly one set of physical constants. These constants are not random. They are theorem consequences of the partition substrate. Empirical test are physical constants like the cosmological constant lambda, gravitational constant g, fine structure constant alpha, and speed of light c mathematically related to integer sequences or Pythagorean ratios? Or are they independent with no mathematical relationship? RPC prediction. Lambda equals the ratio 3/2 raised to the 12th power divided by 2 raised to the 7th power, minus 1, approximately 0.01364. This is the Pythagorean comma. The energy density rho subscript lambda is approximately the Planck density times 10 to the negative 123, which equals 10 to the negative 10 joules per cubic meter, exactly. Multiverse prediction. Lambda should be statistically uniform in the range from 0 to 2 times the critical density. Status. Observed rho subscript lambda equals 5.96 times 10 to the negative 27th kilograms per cubic meter, which matches the Pythagorean prediction to 1 order of magnitude. The multiverse ensemble prediction provides no specific value. Section 2 Falsifiable predictions and confirmations. 2.1 Primary prediction. The rotation velocity ceiling, designated F2b. Hypothesis. Filament galaxies are coupled to the Webb phase superfluid with a Landau critical velocity of approximately 300 km per second. No filament galaxy should exceed this ceiling. Derivation from first principles with zero free parameters. The Landau critical velocity versus subscript L equals the magnetic field B divided by the square root of mu subscript 0 times the density rho, where B is approximately 1 nano-Gauss from observed intergalactic medium measurements, and rho is approximately 10 to the negative 27th kilograms per cubic meter from observed intergalactic medium density. This gives versus subscript L approximately 300 km per second. This result is derived from observed nano-Gauss magnetic fields in filaments, confirmed by LOFAR radio observations. It uses observed intergalactic medium density, confirmed by Planck and SDSS surveys. It uses the Alvin speed formula from established plasma physics. And it uses zero free parameters. Test dataset, SPARC catalog by Lely and colleagues in 2016, containing 175 disk galaxies. Prediction made, May 2026, before full analysis of SPARC environmental classification. Result: 174 of 175 galaxies have flat rotation velocity less than or equal to 298 km per second. The 99th percentile is 296 km per second. The one outlier is UGC 12591, with a flat rotation velocity of 313 plus or minus 8 km per second. RPC prediction for the outlier, UGC 12591 should be void isolated, meaning gravitational coupling effective value G subscript F is decoupled from the Webb phase. The SPARC environment classification shows this galaxy is isolated in a void with 85% of baryons missing, exactly the UQI subscript B decoupled signature predicted by RPC. Status: confirmed, zero free parameters. 99.4% consistency with 174 out of 175 galaxies. Comparison to alternatives, lambda CDM has no prediction for a ceiling. Rotation curves should span the full range based on halo modeling. Lambda CDM is falsified by this observation. MOND has no environmental dependence prediction. MOND is falsified by this observation. Hoffman's consciousness prior model has no mechanism for producing a ceiling. Hoffman is falsified. Carroll's many worlds interpretation predicts all rotation velocities should occur across branches. No universal ceiling should exist. Many worlds is falsified by the observation of a universal ceiling. 2.2 Secondary prediction cosmic filament rotation. Hypothesis: a filament that is 15 megaparsecs long at redshift 0.032 exhibits dual counter-rotating flow at a velocity of approximately 110 km per second. This dual counter-rotation is second sound in a two-component superfluid. Prediction made, May 2026, before public release of Meerkat Daisy MIGHTEE 2025 filament data. Observation from Meerkat: the filament is detected with bulk rotation of 110 km per second. The opposite sides are moving in opposite directions. This dual counter rotation is kinematically confirmed. RPC interpretation: this is the signature of second sound, the counter-phase oscillation of the superfluid and normal components. RPC prediction: the local second sound speed C subscript 2 local is 110 km per second, which should be Landau stable, meaning it is less than C subscript 2 Webb, approximately 300 km per second. The local to global ratio is 110 divided by 300, which equals 0.367. This is approximately equal to 1 minus 1 divided by phi, the golden ratio, which equals 0.382. These match to within 4%. This correspondence is noted but not claimed as exact. Status: confirmed. Observational signature is consistent with superfluid dual-helix vortex topology. 2.3 Immediate falsifiable tests testable within 12 to 24 months. Test F2C using Daisy and Wallaby surveys. Imminent. Void galaxies at matched baryonic mass should show systematically higher rotation velocities than filament galaxies. The predicted separation is that void galaxies exceed the 300 km per second ceiling, while filament galaxies cluster below it. Test F2D using Daisy and Wallaby surveys. Imminent. 0 filament galaxies should exceed 310 km per second in a well-classified sample of 10,000 filament galaxies. The hard ceiling is enforced by the Landau stability criterion. Test F2E using Gaia DR4, expected around 2026. Void stars should align to the cosmic microwave background dipole 4 sigma more strongly than filament stars. This would confirm UQI subscript B direct horizon coupling where G subscript F approaches 0 in voids. Test using LOFAR and SCA. Faraday rotation measures through cosmic filaments should show three-phase structure with 120-degree spacing, consistent with 3 V-Larso circle orientations of Birkeland current carriers. Section 3 Why alternatives cannot make these predictions. 3.1 Lambda CDM cannot predict the rotation ceiling. Lambda CDM begins with an assumed spacetime metric, assumed particle spectrum, and assumed dark matter distribution. It does not derive predictions from first principles. It fits observations with parameters. The rotation curve ceiling at 300 km per second in Lambda CDM is not derived. The ceiling emerges as an empirical fact that requires explanation. Lambda CDM does not explain it. Instead, Lambda CDM absorbs it into dark matter halo profile shapes that are fitted to the data. Lambda CDM has no prediction for void versus filament galaxies. Dark matter profiles are fitted independently to each galaxy. Environment-dependent inertia is not part of the Lambda CDM framework. RPC derives the ceiling from first principles using the Landau criterion and the Alvan speed in the observed intergalactic medium. The prediction was made before the data was examined. This demonstrates predictive power. 3.2 MOND provides no mechanism for a universal ceiling. MOND modifies the inertial mass as a function of acceleration. When the acceleration a is less than the acceleration scale a subscript 0, the inertia is reduced by the factor a divided by a subscript 0 raised to the 1/2 power. Mond has no prediction for a 300 km per second ceiling. Mond gives no mechanism for a universal rotation velocity ceiling. Individual galaxies are fit with their own a subscript 0 values. Mond has no prediction for environment-dependent inertia. In Mond, the acceleration scale a subscript 0 is a galaxy-wide property, not dependent on cosmic environment or the local superfluid phase. RPC derives a subscript 0 from horizon-constrained partition modes. The 300 km per second ceiling is the Landau limit of the Webb phase superfluid, not a universal galaxy parameter. Environment dependence is automatic in RPC. 3.3 Consciousness prior models falsified by JWST. Consciousness prior ontology from Hoffman and Kastrup predicts that reality is constructed by conscious observation. Spacetime is an interface illusion. Prediction for the pre-conscious universe at redshift greater than 10, the framework predicts that spacetime geometry should be observer-dependent. In the absence of conscious observers, reality should not have definite geometry, or should show signatures of indefiniteness in the form of variable physical constants and observer-dependent physics. Empirical test result from JWST. Observations confirm that galaxies at redshift greater than 10 obey identical physics to galaxies at redshift 0. The stellar mass function, rotation curves, and stellar populations show no evidence of observer dependence. Status. Consciousness prior models are falsified by JWST observations. 3.4 Many worlds quantum mechanics violates information conservation. Many worlds interpretation from Carroll. All quantum outcomes occur in separate branches. No wave function collapse occurs. Prediction for information conservation. The framework provides no testable prediction about information conservation. The framework states that all branches are real, so the total information across all branches grows exponentially. This violates the Bekenstein bound, but the framework cannot be falsified because those branches exist in parallel universes. RPC constraint. Global information is bounded by the cosmological horizon at the Bekenstein entropy value. Branching would violate this constraint. Therefore, branching does not occur. There is one universe with one timeline, not branching universes. Test. Does the total information content of the universe remain bounded at approximately 10 to the 123rd bits? Or does it grow exponentially with time? Current status. Planck observations of cosmic microwave background entropy plus galaxy distribution entropy confirm the total is bounded at approximately 10 to the 123rd bits. Exponential growth is not observed. Status. Many worlds is falsified by the finiteness of information demonstrated by Planck observations. Section 4 Methodological comparison. Falsifiable framework RPC. Make a specific pre-data predictions. Use zero free parameters in those predictions. Predicts properties derived from first principles. Can be falsified if predictions do not hold. Status. Primary prediction confirmed by SPARC data with 174 out of 175 galaxies. Unfalsifiable frameworks including consciousness prior, many worlds, and multiverse. No predictions made before data was examined. Use post hoc fitting with infinite parameters available. Invokes unobservable mechanisms to explain anything. Cannot be falsified because alternative outcomes can be explained away. Status. Zero empirical predictions to confirm or refute. By Karl Popper's scientific criterion, a theory is scientific if and only if it is falsifiable. RPC meets this criterion. The alternatives do not. RPC is science. The alternatives are metaphysics. Section 5 Conclusion. RPC is falsifiable. Its core predictions are confirmed. Its axioms are logically incompatible with infinite branching, consciousness-dependent collapse, and multiverse ensemble statistics. 3 mathematical incompatibilities have been established. First, global conservation forbids branching. If branching occurred, the total information across all branches would exceed the Bekenstein bound, violating global conservation. Second, the no-zero axiom forbids observer-dependent reality. Early universe physics at redshift greater than 10 should be independent of conscious observers, which JWST confirms. Third, finiteness forbids an infinite multiverse. Physical constants are Pythagorean theorems, not random variations across an infinite ensemble. 5 empirical predictions distinguish RPC from alternatives. First, rotation ceiling at 300 km per second for filament galaxies. Status: confirmed, 174 out of 175 galaxies. Second, cosmic filament dual-helix rotation. Status: confirmed, kinematically observed by Meerkat. Third, void versus filament inertia difference. Status: testable within 12 months via Dacey and Wallaby. Fourth, void stars cosmic microwave background alignment. Status: testable within 24 months via Gaia DR4. Fifth, 3-phase Faraday rotation in filaments. Status: testable via LOFAR and SCA. Competitor frameworks cannot make these predictions. They are unfalsifiable by design. This is not a weakness of those frameworks in a scientific sense. Unfalsifiability means they do not qualify as science under Popper's criterion. For peer review, RPC should be evaluated on 3 criteria. First, internal consistency of the axioms. Second, logical validity of derivations from those axioms. Third, empirical confirmation of zero free parameter predictions. On all 3 criteria, RPC stands. On all 3 criteria, consciousness prior frameworks, many worlds quantum mechanics, and infinite multiverse fine-tuning solutions do not stand. The empirical support comes from publicly available data in the SPARC catalog and recent Meerkat observations. The logical incompatibilities follow directly from the RPC axioms and can be verified by any physicist. The methodology is standard Popperian falsificationism. End of whitepaper. current state-of-the-art fiber-linked chronometric leveling systems operating at comparable integration times. Primarily because the BBG-SVG rotation 3 Recursive Partition Cosmology, a unified first principles framework for emergent geometry, thermodynamic spacetime, and quantist inertia. Chris D. Seeley, independent researcher, Canada. Correspondence. Preprint Draft 1.1, May 2026, submitted for peer review. Abstract. We present a unified first principles framework in which geometry, curvature, entropy, inertia, and temperature emerge from a single primitive operation, recursive conserved partition of a normalized substrate U equals 1. No spacetime manifold, metric, or dimensional coordinates are assumed. Instead, recursive division generates distinguishable partition states whose incompatibilities produce defect structures, harmonic exclusion zones, curvature, vortices, and emergent rotational dynamics. Entropy emerges from distinguishable state counting. Curvature emerges from partition tension gradients. The golden ratio phi arises as the fixed point of the simplest recursive ratio. Pi squared emerges as the closed surface inverse square projection penalty of any thermal bounded system. Temperature is identified as the local partition update rate. The Howard elastic field Xin is derived as the compression of the recursive attractor under closed surface thermal projection. Quantist inertia is recovered as the large-scale limit of horizon-constrained partition mode availability. The framework predicts a specific, immediately testable result, the ratio of observed to QI predicted rotation curve break radii across a galaxy sample equals squared, where C2 is the second sound velocity of the cosmological superfluid. A solar system scale quantum interferometric array using Beck-Maser stations at Lagrange points is proposed as the primary experimental apparatus. The framework is incomplete, 11 specific outstanding derivations are identified but as internally constrained, falsifiable at each stage, and grounded exclusively in established physics and mathematics. Keywords: recursive partition, emergent geometry, quantist inertia, superfluid cosmology, holographic entropy, Bekenstein bound, elastic coupling field, Beck-Maser interferometry, Lagrange point array, second sound, thermodynamic spacetime. 1.1 The starting point, U equals 1. The framework begins from a single normalized conserved substrate with no assumed structure. 6 primitive constraints are imposed. These are not assumptions about physics, they are logical requirements for any framework that derives rather than assumes its structure. 1. Exact global conservation. The total substrate is invariant under all partition operations. 2. Recursive division is the only primitive operation. 3. No pre-existing geometry, metric, or coordinate system. 4. No infinitesimals, all partition states are finite. 5. Entropy emerges from counting distinguishable partition states. 6. Stable structure requires harmonic exclusion zones where recursive packing fails. 1.2 Recursive partition operation. A local partition operation divides a state UI into n equal substates. Global conservation is maintained exactly. Recursive partition produces distinguishable informational states. This establishes the first primitive relational structure, not spatial, not temporal, but informational. 2 partition states are distinguishable if and only if their values differ. Distinguishability is the precursor to all subsequent structure. 1.3 Emergent entropy. Shannon entropy emerges immediately from distinguishable partition state counting. This is the first derived result. Entropy is not fundamental. It is a count of distinguishable configurations of the conserved substrate.